This video is to help you with solubility rules, and I know I'm going to try to make this a real quick review right before the test. Make sure you know your solubility rules. There's a couple ways that you can learn your solubility rules. First and foremost, make sure that you actually know your solubility rules. I gave you this sheet earlier in your summer note packet. We are going to want to know these rules throughout the year. Now, at first, just looking at these rules as they're presented could be a daunting task. But really, once you've had a chance to memorize these rules, things get a lot simpler. Since there's only really 7 rules, I would make flashcards. In other words, put the rules on one side and then the exceptions on the other side, if there are any exceptions. So step 1, or rule number 1, says all nitrates, chlorates, and acetates are soluble. So when we talk about soluble, we're talking that it starts off clear and remains clear after we pour these together. So if these are the non-metals that are in the solution and they're mixing with some other metal and they combine, allegedly, they're not going to form a precipitate. So soluble means that it starts off clear, it remains clear after the reactions had a chance to get together. Number 2, all alkali salts and ammonium salts are soluble. So what that means is when you're looking at your periodic table, anytime you see something with a group 1A metal, it will never ever form a precipitate. So when those ions are in solution and they come in contact with another non-metal, any one of these, and ammonium, will never combine to form a precipitate or something that is coming out of solution to form a solid. And that's what that second rule implies. So group 1A metals never form a precipitate or are soluble. Okay. Number 3 says all chlorine, bromines, and iodines are soluble except for silver, lead, and mercury 2. Now the mercury 2 is not as big of an item, but definitely silver and lead. We don't want to miss that. And also with lead, the most common charge, there's 2 charges, +2 and +4, but we never ever see +4. So it's always, just remember lead. Anytime you see lead, it's going to form a precipitate. You're never going to see the +4, I promise. Number 4, all sulfates are soluble except with cold beer and Pizza Hut. Now, this was a statement given to me from a student, and they're not actually in the order of cold beer and Pizza Hut. But when you look on the periodic table, okay, all sulfates, SO4, when it comes in contact with a metal, will remain soluble, except with calcium and barium. There's your cold beer, and then your Pizza Hut is your lead and your mercury. So those are the only 4 metals that when they come in contact with sulfate actually come together and form a solid. So that's what that rule is stating. So you don't really need to remember those 4 metals, just remember all sulfates are soluble except with cold beer, calcium, barium, and Pizza Hut. And again, look at your periodic table. Always have your periodic table in front of you whenever doing solubility rules. Number 5, all hydroxide salts are not soluble except, and then again, what this is saying is calcium, strontium, barium are soluble. Easier way to remember this, all hydroxides form a precipitate except with group 1A and calcium on down. Now, true, the rule only states calcium, strontium, and barium. Doesn't talk about radium, but we're never going to make a compound with radium. So it's just so much easier to look at your periodic table and say group 1A, calcium on down. So if you put magnesium with hydroxide, you're going to get a PPT. You put beryllium with hydroxide, you're going to get a PPT. But any one of these are soluble. Okay. Number 6, all sulfides, carbonates, chromates, and phosphates are not soluble, except when you've got a group 1A metal or ammonium. So those are the salts, or I'm sorry, those are the non-metals that will always form a PPT unless it's with group 1A. Then again, group 1A says, well, it'll never form a PPT. And then this one down here, we don't really talk about it that much, and I don't really test you on it in the fall. I'll talk to you more about that as we get closer to spring and the AP exam. But all metal oxides are not soluble. In other words, like calcium oxide, copper oxide, there's a whole list goes on and on. those are not soluble, except group 1A and ammonium. Okay? So, knowing these rules is going to be very, very beneficial. However, when you start doing the work, okay, this is a different example from what I showed you in class, okay, but this is still the same type of application. I stated to you guys in class that what I want you to do when you see a question like this is to first of all mark off, cross off all the things that will never ever form a PPT, okay, and they have to never form a PPT in all cases. So again, what that's saying is, make sure you cross off anything that's nitrate, chlorate, or acetate. That's the first thing you want to look for. So when you look at your thing here, say, are there any nitrates? I don't see any nitrates. Are there any chlorates? Well, that's chloride, not chlorate. But here's a chlorate. Oh, great, I got two chlorates on here. I didn't mean to do that. And then nitrate and acetate. I don't see any acetates or anything else there. Okay, so those are the nonmetals that will never form a PPT. Then the next thing you want to look at is the other one. The first two rules state who will never form a PPT. So all alkali salts, okay, or alkali ions in group 1A, and ammonium. So we go back to our list here, and we want to look for anything that's in group 1A. Sodium is in group 1A. Cross it off. Ammonium, we put it in group 1A. And that's it. Okay, so those are the only things that we can actually cross off. Now, here's what I would not ever do. I wouldn't look and say, ooh, chlorine. Chlorine's soluble for a lot of instances. That's true. However, chlorine will form a PPT with silver and lead, and we don't want to do that. So we don't want to cross off the chlorine because there could be a possibility that we could form a PPT when we have silver and lead. So don't cross those off. All right, so now that we know that we're not going to do anything with these guys, it becomes a little more, or a little easier for you. So let's go ahead and do this. So we're going to mix flask 1 with flask 3. Well, the good news is we've already crossed off both non-metals, and we're never going to put metals with metals. They never combine. All right, it's always going to be an ionic compound, a metal with a non-metal. So since both of the non-metals are actually the same, they're not going to form a PPT, and we have only iron and silver left. So that means that when we mix 1 with 3, those two flasks together, nothing's going to happen. When we mix 2 and 5, okay, so we have both of our candidates here. That means that something possibly could happen. And then with oxygen, well, barium with the oxygen is looking pretty good. And then sodium with the hydroxide, well, sodium's group 1A, so we're not even going to look at the sodium. But barium is definitely not a group 1A metal. All right, so since barium's in group 2A, that means that we do have, according to our rule, that states that all metallic oxides are not soluble except group 1A and ammonium. So that means that we do have a PPT. Also, if we do have a PPT, let's get in the habit of writing it out. So we know that the oxygen has a -2 charge, barium has a +2, always write the metal first. So barium and oxygen. So barium oxide. There's 1 barium, 1 oxygen. All right, number 3, we have 6 with 4, so here and here. So again, that metal's already been eliminated, so we only can look at copper with the carbonate. And again, when we talk about the rule, I can't remember what number it is, but all carbonates, chromates, sulfides, and phosphates are not soluble except with group 1A or ammonium. So we do have a PPT with our copper and our carbonate. Now, what's the charge on the copper here? Well, remember that copper could have multiple charges, but we want to key off of our non-metal. So the sulfate has a -2 charge. So we know that we, A, have a PPT. So we're going to have our, wait a minute. No, not sulfate, my bad. No. We have carbonate with copper. So it's copper carbonate. And since the copper has a +2 charge because the sulfate has a -2 charge, and the carbonate has a -2 charge, that's balanced as written. Actually, let me change that color just to mix it up a little bit. So here we have copper to carbonate. Okay. All All right, number 4 with number 7. Okay, so 4 with 7. Again, the chlorine's not going to do anything since the metal in this flask has been eliminated. So now we're going to focus on manganese and carbonate. And again, carbonate will form a PPT unless it's with group 1A. So we will have a PPT here. And we're going to have manganese. I'm going to write it off to the side here. So we know we're going to have manganese, but I don't know what the charge is. Manganese has a multiple of charges as well. So we look at the nonmetal. Chlorine has a -1 charge. Therefore, the manganese has a +3 charge. And the carbonate, is it the right? Yeah, 4 has a -2 charge. So that means that we need 2 of those and 3 of those. So Mn2, parentheses, CO3, close the parenthesis, 3. So manganese with a charge of +3, carbonate. Okay. All right, flask 2 with flask 1. Well, we have silver with the oxygen and the sodium with the chlorate. Well, the sodium and the nonmetal here are gone, so our only option is silver with oxygen. And again, silver is not a group 1A metal. Silver's way over here, right there. So silver oxide does form a PPT. So we're on a string here. Look, let me change that color. So silver's a +1 charge. That means we need 2 of those and oxygen. Flask 3 with flask 4. Again, the ammonium and the chlorate definitely aren't going to do anything, but does iron and carbonate form a PPT? Again, all carbonates form PPTs except with group 1A. So this does have a precipitate. And iron, since there's 2 chlorates there, that iron has a +2 charge. So Fe with a +2 charge, and what are the numbers? 2 and 4. So carbonate also has a -2 charge, so iron 2 carbonate. All right, 2 and 4. Wait a minute, I just did 2 and 4. Whoops, 3 and 4, my bad. 3 and 4. That's actually the answer to the next one. Daggone it. So 3 and 4 is, oh, I did that right. Iron carbonate. Okay, now, looking at 2 and 4, the sodium's gone and the ammonium's gone, so the only thing that's left are nonmetals. So you don't put nonmetals together to do anything, so that's clear. All right, 6 with 3, so 3 and 6. So iron with the sulfate, copper can't do anything since it's with the chlorate. So iron and sulfate, does that form a PPT? All sulfates are soluble except with cold beer and Pizza Hut. Now the cold beer here, let's see, that's number 6 and 3. So the copper is not part of the cold, it's calcium. So so iron with the sulfate is actually clear. Because again, when you hook sulfate up, the only thing that's going to form precipitate is calcium, barium, lead, and mercury. Okay, let's scoop this. All right, so number 1 and 7. So 1 and 7 over here. So silver with the chlorine. Again, all chlorine, bromine, and iodines are soluble except with silver and lead. So in this case, we do have a PPT. So silver chloride. And silver has a +1 charge, chlorine has a -1 charge. Manganese isn't going to get to do anything with the chlorate over here. And then 5 with 3. So barium isn't going to do anything with the chlorate. Iron with the hydroxide. Ooh, hydroxides are not soluble. Hydroxides are not soluble except with group 1A and ammonium. So since, what is it? Is it iron? I thought it was iron. Iron, 5 and 3. So yeah, iron. So since iron's in the middle here, okay, it's not over here in group 1A or calcium on down. So since iron's located there, then that means we do have a precipitate, and it will be iron. And what's the charge on iron? So +2, and it's, what are we looking at? 5 and 3. So iron hydroxide. All right, I have another one of these on the next page. But before we go to that one, I want you to try these, because here's another way of doing this. It says write the complete equation if there is no reaction, write NR. Actually, I want to change that. I want you to only write the net ionic equation. Okay? That'll actually be the only thing that we do from here on out. Okay? And that's what I was doing in my mind. And some of you need to write out the equation to do that. I would hope that you would get to the point where you would start to go like this. Okay, silver, so if we're going to react flask 1 with flask 6, okay, then you're going to say, okay, well, silver's going to go with the sulfate. Okay, silver with sulfate, is that soluble or not soluble? Does it form a PPT? Very good. It is soluble. It does not form a PPT. Silver is not part of the cold beer Pizza Hut. So by doing that, like pointing to it, and on my paper, I'll point to these and go, okay, sodium with the chlorate, nothing happens. Silver with the oxygen, ooh, according to solubility rules, something happens. So hopefully you'll get into that pattern, or you'll be able to get that quick. Now with the net ionic equation, we only write down those things which form the precipitate. Okay? And let me do an example here on this first one, and I'll write the ionic equation, and then I'll show you the net ionic equation. Actually, I'll just write the equation, then I'll show you the net ionic equation. So in this case here, we have to be able to translate from sodium carbonate. So sodium has a +1 charge, carbonate has a -2 charge, so that means we need 2 of those, and iron 3 nitrate, so nitrate NO3, which means that iron's a +3 charge, nitrate looks like that, so -1. So we have to ask ourselves, okay, well, what's going to form here? Move those over. Now let's see what's going to be formed here. And this is a double replacement reaction, which they all are. So sodium's going to go with the nitrate. And then the iron will go with the carbonate. Okay? Now, before you go and balance this out charge-wise, ask yourself, are you going to have a precipitate form? Because if not, you're simply going to write NR. You're not going to waste your time balancing everything out, the charges on the molecule, and then balancing the number of atoms on both sides. Before we get to spring, I may throw in a no reaction, but once we get into spring, everything's going to react. So that's a good heads up. So we know that everything's going to happen here. Since this iron has that should be a 3 there. Since we know that iron has a +3 charge and carbonate has a -2, that means we need 3 of those and 2 of those. The sodium nitrate is as it's good as written. However, we need to balance the number of atoms on both sides, go ugly early. So we have 3 carbonates there. So we need a 3 here. So that means we have 6 sodium, 6 nitrate. We have 3 there, put a 2 there, 2 iron. We got it. Okay. You'll get fast like that again, okay? You were good last year or when you took honors chem. All right, so now when I'm asking you for the net ionic equation, I'm looking for that which forms the precipitate. According to solubility rules, sodium nitrate does not form a precipitate for 2 reasons. It's a group 1A metal, they never form PPTs, and you have a nitrate, and that never forms a precipitate. So that one's out for 2 reasons. The iron 3 carbonate, it does form a precipitate because of the carbonate. The carbonates form PPTs except with group 1A and ammonium as their metal. So here's the net ionic equation for this reaction. We have 2 irons, well, we have 2 irons here. So we have 2 Fe with a +3 charge, and we show the charges in the ionic equation because that's what's happening. These are soluble, these are soluble, these are soluble, this forms a precipitate. It comes together and forms a solid. So we have 2 iron with +3 charges, and we have carbonate. We have 3 carbonates, boom, boom. So we have 3 CO3s with a -2 charge. So we show it on the reactant side as ions. That's pretty typical. And then we're going to put them together as you have it here. Okay. Now, Writing the net ionic equation, we never show what's called spectators. Spectators are ions that do not form precipitates or PPTs. So we never show spectators. This would be the correctly written net ionic equation. Okay. All right, try the next one on your own and pause the video. Give it a shot here. Try it out. Let's get this over. Okay. All right, you've had a chance to work it out. So we have aqueous silver 1 chlorate. Yes, I put the Roman numeral in there because that's how you'll see it on the AP exam. So we have silver chlorate, ClO3, reacts with aqueous ammonium chloride, ammonium, NH4Cl. So +1, -1, +1, -1. They're balanced as written, which is nice. And then we're going to switch partners. So we're going to have ammonium with the chlorate. Always write the metal first. ClO3. And then we're going to put the silver with the chlorine. And again, since these all had chlorine. Since these all had +1 or -1 charges, it's balanced as written as well. Okay, so solubility rules. Who's going to form the precipitate? Well, obviously not this one because ammonium and chlorate, again, just like up above with the sodium nitrate, are soluble because we treat it as a group 1A metal and the chlorate is also soluble. However, silver chloride, that does form a precipitate because again, all chlorines, bromines, and iodines are soluble except with silver and lead. So again, when writing the net ionic equation, show those who are involved. Silver with a +1 ion, with chlorine, the -1 ion. If you want to put the ones, that's fine, doesn't matter. Forms silver chloride. Okay, that's the net ionic equation. I would suggest doing this top row here because it allows you to balance the number of atoms and the charges as well. All right, so again, try these next two on your own. Pause the video, and I'm going to work it out very quickly. So actually I'm going to pause the video and then have the answers up here just to speed this thing up. Okay, so here's my reaction where I have lithium oxide with the barium acetate forms lithium acetate and barium hydroxide. Who is my precipitate? Again, when you look at all hydroxides, group 1A and calcium on down. Well, in this case, barium is in group 2A. Right there. So is barium hydroxide soluble or not soluble? Hopefully you said that it is hydroxide. There you go. Group, well, there it is, barium, are soluble. So we have ourselves a no reaction. Again, lithium's a group 1A metal. Acetate is never going to form a precipitate. So there's your example of a no reaction. D, you had a chance to do. If not, pause the video, try it on your own. So here are my reactants, copper +2 with sulfate, and how ironic because copper sulfate is blue. Lead nitrate, lead +2. So again, this doesn't do anything. However, all sulfates are soluble except with cold beer and Pizza Hut. So the pizza is our situation here. So we have our lead sulfate. So again, writing the ionic equation, lead +2, sulfate -2 forms lead Make sure you're balancing charges, the number of atoms on both sides as well. All right. Try this next one on your own. Seriously, pause the video. Do what we did in the first one, okay? All right, you've had a chance to work this out. Go through, cancel out all the things that cannot form a precipitate. Acetate does not form a precipitate. Sodium cannot form a precipitate. Cobalt and chlorine can form a precipitate, so don't cross those out. Ammonium cannot form a precipitate. Nitrate cannot form a precipitate. And then potassium cannot form a precipitate. Zinc can, sulfate can, and chromate can. So that's the first thing. Go through and cancel those out so that you don't accidentally put them as something form a precipitate. And again, know your solubility rules. Because if you know your solubility rules, this flies. So 1 with 3. In other words, cobalt won't form a precipitate because its non-metal has already been crossed out. However, lead and chloride, you have to ask yourself, can lead chloride form a precipitate? All chlorines, bromines, and iodides are soluble except with silver and lead. So, lead chloride. Again, lead has a +2 charge. Chlorine, -1. 2 with 5. Again, the sodium and the nitrate, they're out. So now you have to consider the silver and the phosphate. And again, all phosphates, carbonates, chromates, and sulfides are not soluble, except group 1A. Silver is not a group 1A. So we do have another precipitate. So silver, what is it? 2 with 5. So silver, write it over here. Ag3PO4. Silver phosphate. 6 with 1. So zinc acetate's not going to do anything. Lead sulfate. Again, all sulfates are soluble except with Cold Beer Pizza Hut. The lead is your Pizza Hut. So, okay. 4 with 7. Both of the metals are out. There's no way you could put the two non-metals together. Clear. 6 with 2. So zinc phosphate, and that's it because the metal's out over here. So zinc and phosphate are your only option. All phosphates, carbonates, chromates, and sulfides are not soluble. Are not soluble except with group 1A. So we do have a precipitate, and it's zinc phosphate. So ZN3PO4 2. 3 with 6. Ooh, we could have 2 in this case. Maybe. So cobalt with the sulfate. All sulfates are soluble except with Cold Beer and Pizza Hut. The cobalt is not cold, even though it looks probably like it should be. So cobalt sulfate is out. What about zinc chloride? Well, all chlorides, bromides, and iodines are soluble except with silver and lead. I don't see silver or lead. Clear. Okay. 2 with 4. Metals are out. That makes it really quick. If you notice that the two metals are out, the two non-metals are not going to get together and form a PPT. 6 with 3. Wait a minute, we just did that. Yeah, we did. So again, clear. 1 with 7. Okay. Lead chromite because the potassium's out here and the acetate's out of here. So we have to ask ourselves, will lead chromate form a PPT? All sulfides, carbonates, phosphates, and chromates are not soluble except with group 1A and ammonium. So yes, we do have a PPT. Lead has +2, chromate has a -2, so lead chromate, PbCrO4. And the last one, 5 with 3. So we have silver with the chlorine because the cobalt's not going to do anything with the nitrate. So will silver chloride form a precipitate? All chlorines, bromines, and iodines are soluble except with silver and lead. So yes, we do have a PPT. Okay, and I think that's it for this. But again, if you need to, redo this homework again, I'm going to post the link to this worksheet right below the video link and also on the YouTube video. And again, I hope this video has helped.